All right, AP Stat students, it's time for your first FRQ walkthrough, and there's going to be a lot going on in this video. Statistics FRQs are graded in a very unique way. I mean, really every FRQ or open response question is, but one thing I want to do as I go through this is show you that really everything you need for this is accessible on the website. So let's say you first need your Z-table or T-table. I've linked to that right here. I'm going to open that in a new tab. And I'm just going to have this hovering around on my secondary screen on the bottom. You might want to print this out if you can. There we go. Up next, let's have our FRQs pulled up. Open link in new tab. And also the scoring guidelines. Open link in new tab. Okay, so I have my FRQs. I can put them in their own window. I've got the scoring guidelines that I'm not going to look at. Now the thing about this is I have not studied directly for the AP exam. I haven't actually really reviewed material other than just making the videos with you. I'm totally open to getting things wrong without looking at this guide, unless, of course, I just make some really big mistake overthinking or underthinking. What I'll usually do is I'll make a second video and at least tell you I made a big mistake and definitely didn't get all the points. So again, the idea is you should be actively reviewing. You should be doing a lot more work than I am for your AP exam. So also things to keep in mind. Your goal should be to give yourself 15 minutes per FRQ. That's technically how the old timeline worked itself out. Now this year, one question you get 25 minutes, the other you get 15, but really, as long as you give yourself 15 minutes a question, you should be okay. Except when you actually get to the AP exam, make sure you give yourself the full 25 minutes on question 1. Anyways, we wanted to do questions 1 through 4. In this video, I'm just going to get through question 1, and I'm going to show you really how they graded everything. Now, I might not get too into the nitty-gritty of the detail of what they were doing, but I'll just give you my quick idea of what I think the answer is and how I would have done based on what I answered. This video is honestly mostly about figuring out how to interpret that whole scoring guideline, less than the actual stat involved. So, they want to identify and interpret the estimate of the intercept of the least squares regression line. So I'm going to give you some extra background information here. Remember that a regression line looks like, on the reference sheet, a plus bx. And a regression line is essentially saying whatever you predict y to be is going to be based on some values a and b that you can calculate times x. So let me just show you that in the reference sheet. There it is. And we want to know what the intercept is. Now that intercept is a. The other thing about an intercept is it's a constant value. It's never changing. Whatever x is, a is remaining the same. With that being said, when you find the least squares regression line and you have this data output, a is going to be whatever's underneath coefficient for constant. So a, 72.95, and b, the slope, is 174.4. So that's our least squares regression line. They want the estimate of the intercept, that means y-intercept. So I'm going to say the intercept estimate is 72.95. And then they want me to interpret it for the least squares regression line, and I'm just going to verbally interpret this. The intercept is the predicted, because it's coming from the regression equation, the predicted wait time in line if there were 0 customers in line. That's what a y-intercept is. A y-intercept essentially says if x is 0, what is y? Now this does make contextual sense. If you're a shopper in a store and you get up into the line and there was no one there before you, it's still going to take about 72 seconds from when you enter the line to when you leave. It's just you were the only person there, so your wait time is going to be pretty short because they just have to scan your items and you go. As you add customers, your wait time gets longer because you have to wait for all those customers to have their items checked out. So again, one thing about interpreting the intercept is you want to answer if it makes contextual sense in the problem, and you want to make sure you include the context of the question. So when there's 0 customers in line, you would expect to wait 72.95 seconds from the time you enter the checkout line until you're finished checking out. 72.95 seconds. Okay, up next, identify and interpret in context the coefficient of determination r squared. All right, now there's 2 things in here that have r squared. One of them is just r squared. One of them is r squared adjusted. For AP Stat, never look at r squared adjusted. So r squared, the coefficient of determination is its name. That's something you might want to write down on a reference sheet, is 73.33%. Now actually that really means that r squared itself, if they're giving it to you as a percentage, I believe is just 0.7333. I just want to make sure I get that right. This is my first time I'm going to be looking at these scoring guidelines. Okay, so I actually can write it as a percentage, but if I don't write it as a percentage, that's valid as well. But evidently you could have written it just as it was, so which is also 73.33%. Now R squared has a very particular cookie cutter sentence. R squared is the percentage of variation in the response variable, so that's in checkout time, that is explained by the regression model on customers in line. All right, and I believe another way that you could write this is 73.33% of the variation in checkout time in the regression model can be explained by the customers in line. Essentially, you're trying to find some kind of, regression is all about finding correlations. That's why it's called a correlation coefficient. So how much does the x variable explain, explanatory, the behavior in the y variable? And again, hopefully it's intuitive that, it does make a lot of sense that the majority of how long you're going to spend in line is based on how many people are in line. Of course, some of the other variation would probably be how many items you have and another customer has, but we're not really here to investigate that. Again, look at the scoring guidelines. 73.33% of the variability in the time it takes a customer to finish checking out, including wait times, they're being a little more descriptive, can be explained by knowing how many customers are in line. So in other words, the regression model on customers in line, or you might just want to say explained by the explanatory variable. Okay, next, part C. I love this. One of the points was determined to be an outlier. Circle that point. Hopefully you see which one it is. It's definitely this one. And explain why that point is considered to be an outlier. Now, here's the best answer. This point has the largest absolute residual of any point, and that is one way of essentially describing that. In other words, it is it has the largest vertical distance between itself and the regression, or you might want to say least squares regression line. Again, the regression line is there to predict everything. All these values are fairly close. There's, of course, always some variation. You're never going to have a perfect model, but this one is so far off from the model. Something happened here. Who knows? We don't have to know. But theoretically, think about this. What if there were 3 customers in line, but for some reason, all of them only had 2 items? For some reason, whatever reason, they all just had 1 or 2 items. They all got to check out really quick. So even though there were 3 customers in line, it didn't take any of them a long time. But that's clearly an anomaly from the average behavior. You don't need to think about that at all. You just need to, go to my scoring guideline. You just need to circle the correct point here, again, and it's an outlier because the combination of x values and y values differ from the pattern of the rest of the data. Specifically, the value in y is much lower than expected. All right, that's what I was talking about, the largest vertical distance between itself and the regression line. It's much lower. That also means it's going to have the largest residual. Remember, a residual is the value of the distance. In this case, it's actual minus predicted every time. Now, the actual value is the y value of the data point, which is very small. And again, you'd have to assume it's maybe close to 70, because remember, this dot right here, this y-intercept is 72, so it's about the same height, so it's approximately like 72, minus the predicted checkout time was around, 530. So you can see that's a very large difference between the two. That's the value of your residual. Okay, now we got through the questions in about 10 minutes. I actually still had 2 minutes of introduction, so yeah. Now what I want to do is really break down how you get scored here. It's very complex. First thing when you do this is you want to read the question And you might think that you got it right based on what you wrote, but really this is the solution. This is nice to know, but you need to really spend your time reading each of the scoring parts. Now in statistics, you can get E's, P's, and I's. So let's see how you get an E in part A. Now remember, I verbally gave you some of the information here, but you get an E if you say three things. You identify 72.95 as the intercept, okay, check. You communicate the concept of a y-intercept that includes both time and 0 customers. Now in my verbal description, I did that. I said if there were 0 customers in line, by the time you enter the checkout line, you would assume it would take 72.95 seconds to complete. Okay, I said something similar to that. Now the other is, and I did say this, but I actually I said estimates, there we go. You have to indicate that this is a predicted or estimated value because you're using an estimating equation. A regression line is an estimation, it's not exact, right? Now, if you said all three of those, then you got an E. If you mentioned only 2 of these, then you got a partial. And if you didn't mention, if you mentioned 1 or none, you got an I. Okay, moving on. They give you some other things right here. Like writing this out isn't enough to identify the intercept. Now, I was just showing you that to show you how you form the regression equation for sake of review, but you actually have to specifically just talk about this value, right? Unless intercept is explicitly labeled. A regression equation can't be used to satisfy component 3, right? Incorrect equations are treated as extraneous and don't affect the scoring. So let's say for some reason you wrote this equation down and it was totally wrong. That's okay as long as you called the intercept correct. All right. Now a response that interprets this as a slope, that would be a big no-no. Definitely doesn't give you any credit for 1 or 2. Okay, part B. Did you identify the 73.33? Again, never look at R-squared adjusted. That's part 1. Did you give a generic interpretation of R-squared? So again, percent of the variation in checkout time that's explained by the customers in line. And then it doesn't include context. Now again, notice I didn't just say percentage of variation explained by the explanatory variable. I said the percentage of variation in checkout times. Now I could be a little more descriptive there. That's explained by customers in line. That is the context. All right. So there's your cookie cutter sentence involving explanatory and response, but make sure you're addressing what the actual prompt of the problem has. Again, if you hit all 3, you got your E. If you got 2 of the 3, or if you satisfied the 3 components but reverse the roles of customers in line and checkout times, in other words, if you say the percent of variation in customers in line explains the checkout time, that's not really, you can't really predict customers in line. It's kind of the other way around. Because there's X customers in line, you expect this checkout time. You don't really want to think about that the other way around. All right, now in other words, just make sure that you are always saying the percentage of variation in response is explained by the explanatory variable. All right, now there's a lot of extra notes here, and they give you a bunch of interpretations of how you can interpret this. So if you don't remember how to interpret R-squared, you might want to write one of these down and just realize that you need to talk about Y and X specifically. It's nice that they have that all there. Again, make sure you have predictions on average in your coefficient, or sorry, those are incorrect things here. You're not predicting, it's not an average. And again, make sure you mention time or customers. So you don't have to mention both, but you have to mention at least one to satisfy the context. Okay, last but not least, did you correctly circle the point? And do you describe the unusual feature, again, the fact that the value of y is much lower than expected. The residual is large, so I kind of said both of those. You only have to say one. So again, make sure you identify the correct outlier, and make sure that you also mention why it's an outlier to get both parts. All right, so in general, really quick, I'm going to have to speed up this video. It's 17 minutes long. I have to shorten it to fit into AP, or to fit into YouTube's timing. But again, the key point here is stats has to be very descriptive. Never feel like you're writing too much. You usually want to give a sentence or two for every mathy answer you give if it says explain or give a reason. Now, last but not least, we have to cover this. How do you get a score of 1, 2, 3, or 4? Here's how it works. Count up how many E's and P's you have, and then figure out which of the categories you fell into. Now, I'm going to skip that for this question. Hopefully you kind of figure out how you did.